Hi there, this is video section 1.5, solving inequalities. All right, so if you get out your video notes, let's see what we have here. Let's finish writing this. Okay, we've got one vocabulary word, set builder notation, and in this unit, we're going to solve one-step inequalities. We're going to solve multi-step inequalities. So let's first look at what do we need to know to solve them. Well, you need to know the properties for solving inequalities. We'll start with the addition/subtraction property of inequalities. Right? We have the same thing for equalities, which said if we add or subtract one value to the left of the equality, now we change that to inequality, we must do the same thing to the right side and it not make a difference. So basically, what you have going on here is if I have A is greater than B, and I take A and I add or subtract C, it's still going to be greater than B. I have to do over here, and it's still going to be greater. All right, so we call that addition/subtraction property of inequalities, just like equalities, except for you have an inequality sign instead. So let's look at the example, our first example on our video note sheet. It says solve y minus 6 less than 3 and then graph the solution on a number line. All right, so our problem is y minus 6 is less than 3. We're going to add 6 to both sides. This cancels out, so we have y less than 9. And then we come to our number line, we say 9. It's an open circle because it's a less than, and it's going to go this way. And there is our solution. So I want you to pause the video, do guided practice 1A and 1B. All right, we're back now. So let's look at our next example, example 2. This one uses the multiplication/division property of inequalities. Okay? Now the book gives you this long key concept box. We're going to make it simple. Just like in an equality, whatever we multiply or divide one term by, we must do it to all terms and not change the value of the equality or inequality now. It's the same as inequality. When you multiply or divide by a positive number, you just do what you do to an equality sign, an equation, except for you have an inequality sign instead of an equal sign. Now, if you divide by a negative number, you must flip the inequality sign, okay, in order to keep it a true statement. If you don't, it will no longer be true and you'll get a wrong answer. So let's look at what the book has to say about that. So the book wants to give us, so here's the addition/subtraction. The book's going to give us this long thing. Basically, they're saying it's the same property as an equality, multiplication/division property of equalities. The only difference is we have an inequality sign, and then the one additional difference is that when you multiply or divide by a negative. Not when you have a negative times a positive. It's when you multiply by the entire equation by or divide the entire equation by a negative. You must flip the inequality sign. So let's look at example 3. All right. But before we get to that, let's look at our definition of set builder notation. All right. So it's just a way, set builder notation is just a way that a solution to an inequality sign can be expressed. Example, it can say y such that y is less than 9. That was our solution set in example 1. All right, so that's called set builder notation, and that's just a way of expressing your solution. We'll learn another way a little bit later. All right, so let's go back. Let's do example 2. It's negative 4.2 less than or equal to negative 29.4. Okay, they want us to solve, and this is x here. Sorry, I missed the x. Solve it and then graph it. So what are we going to do? We're going to divide by negative 4.2 because we want this x, we want this negative to go away. We want this to be positive x. So it leaves us with positive x. So we have an inequality. So guess what? We must flip the sign. We divide this by, we're dividing by. Negative divided by negative is a positive, and when you divide these, we get 7, and now we can graph 7. We put a circle, we fill it in because it's greater than, and how would we write this as set Below notation? We would say x such that x is greater than or equal to 7, and we can check it. We can pick 8 and put it in here, and we're going to get a true statement. All right, pause it, do guided practice 2A and 2B. So now we're back, and we're going to look at example 3. Example 3 has more inequalities, except for now we have a multi-step. So we don't let fractions and inequalities and negatives scare us. We still solve, we still use PEMDAS, we still use the same rules. All right, so let's look at this example. So we have negative 4c less than or equal to 5c plus 58 divided by 6. So we have to first of all determine how many terms we have. We have one term on the left, one term on the right. Okay, one term here. And this, you might think this is 2 or 3 terms, but because of the division bar, we're going to tie the numerator together, even though there's more than one term there, with the denominator as one term. So let me rewrite this so it's a little bit neater. So we're going to have 5c plus 58, and that is completely tied together. This whole thing, because the division bar, is tied as one term. So I need to get rid of this 6 first, because that's the only way I can break these parentheses, or I divide each one of these separated like I would a fraction. That's too complicated. So it's easier if I just multiply this term by positive 6 over 1. So my property says as long as I do it to every term, I only have one term here. So if I multiply this, put it over 1, I'm just multiplying fractions. Now I multiplied by both the entire equation by a positive number, so I don't flip the inequality sign. These two cancel out, and you're left with 5c plus 58. Here, numerator times numerator, even though I have a positive times a negative, I'm not multiplying this term by a negative. This is what I'm multiplying by. It's by a positive. So I don't flip the sign. So make sure you don't get those two mixed up. So now can I subtract 5c from both sides? Yes, using my addition slash subtraction property. And I get negative 29c is less than or equal to 58. Now I need to get rid of this, so I need to divide by a negative 29. Oops, I'm dividing by a negative, so guess what happens to my inequality sign? It flips, and I get c less than negative 2. Now, how do I graph this? I go to negative 2, circle, fill in, because it's a less than or equal to sign. It goes here. In set Below notation, I would say c such that c is less than or equal to negative 2, because this is the variable I'm using. All right? So I want you to pause it. I want you to do the next 4 guided practices, which are 3A, 3B, and 3C. All right, welcome back. So now that you've done those, let's look at this. We can use these in a real-world solution. So it says, write and solve an inequality. So Enrique's company pays Solemn to advertise on Solemn's website. His website earns $15 per month plus 5 cents for every time a visitor clicks on the advertisement. What is the least number of clicks per month that Solemn needs in order to earn $50 per month or more? So he wants to earn at least. This is really important. At least means what? Greater than or equal to $50. So let's first define what our variable is. So we're going to let C be the number of clicks on his website. Okay, so what does he make? So he earns $15 per month, which is a flat fee, plus he earns 0.05 cents for every click. And we said let C equal the number of clicks. So here's our inequality. Now can we solve it? Yeah, now we just use basic geometry. Algebra, minus 15. So you have 0.05 C greater than or equal to 35. Now, we're subtracting, adding. We don't flip it, so don't get that confused. It's only when you multiply or divide. Know the two properties. All right, so now we're going to divide by a positive 0.05 to both sides. So I'm left with C greater than or equal to 700. So C is number of clicks. So in order to make at least $50, he must have at least 700 clicks. All right? Okay, stop the video and we'll see you in class.